Let's look at section 12.3 notes, inscribed angles. An angle whose vertex is on the center or is on the circle and whose sides are the chords of the circle is an inscribed angle. So we've looked at angles that were formed from the center of the circle, which was the central angle. Now we're looking at inscribed angles. Next lesson we're going to look at angles on the outside of the circle and some that are on the inside but not at the center. So in its inscribed angles have a vertex somewhere on the circle. It doesn't have to be directly in the middle, it can be anywhere on the circle, and it's going to open up to an arc. The arc that it opens up to is called the intercepted arc. Angle CAB is our inscribed angle. It opens up to arc CB, which is our intercepted arc. Now you may hear me say it, this is the angle it opens up, or arc it opens up to, the intercepted arc. Okay, it's the angle, the inscribed angle's arc. So in this case, CB is our intercepted arc. In theorem 1211, we discovered the relationship between the angle and its arc that it opens up to, or the intercepted arc. It is going to be half the measure of the intercepted arc. So measure of angle A is equal to 1/2 of the measure of arc BC. So one thing I want you to remember is that when we talked about the central angles, and let's say this angle right here is our central angle. There's the center of it. We have an angle formed going to the same arc BC. And if this arc was 60, if this angle is 60, then the arc that it opens up to, BC, would be 60. And the inscribed angle is going to be half of that, which means this inscribed angle would be 30. The further you get away, the smaller it becomes. So now let's look at an example. All right, so let's look here. In this diagram, we have angles A, B, C, D, and E. These are all inscribed angles. And then the angles that are numbered here are also the inscribed angles. These are vertices that are on the circle, and we have angles 1 through 7. So what we're going to look at here is we're going to go through and we're going to describe and name the arcs that they open up to. So angle 1, if we follow it up here, it goes to E, the other chord goes to D, so that opens up to arc ED. For angle 2, find angle 2 right here, the two chords follow it on to B, the other side goes to C, which means it's going to open up to arc BC. Angle 3. Angle 3 is here, it opens up to A, opens up to B, which means it's arc AB. Angle 4 opens over to E, opens to D, so it means it also opens up to arc ED. So we can draw the conclusion if these two both open up to the same arc, then they should be the same inscribed angle. So their angles are congruent. Let's look at 5 now. 5 opens up to E, opens up to A, which means it's going to be arc AE. Angle 6. Angle 6 opens up to D, opens up to C, which is going to be arc CD or DC. It doesn't really matter which way you write it. And the last one here, angle 7, opens up to A, opens up to B, so that's arc AB. All right, so these are the arcs they open up to. So now let's take a look at what happens when we plug numbers in. So now we're going to find the measures of each of these inscribed angles. Now what we have is we have 80 degrees is from A to E, 36 is A to B, 96 is from B to C. We don't have C to D, but we know E to D is 100. So the first thing I would do is we need to figure out what is the measure of arc CD. How many degrees is it? Well, we know that this is going to be, it's a complete circle, so the sum of this should be 360 degrees. Another thing I want you to notice is that this is 80, this is 100, which means it's 180 degrees. So from A to D, so AED is 180 degrees, which means this AD is a diameter, which means this is also going to be 180 degrees. So you can do 36 plus 96 and then subtract that from 180, or you can add them all up and subtract from 360. Either way will get you the same measure of 48 degrees. Now, let's take a look here at angle 1. We said it opened up to ED. ED is 100 degrees. That means that it's going to be 100 divided by 2, which is going to be 50, because the inscribed angle is half of the arc it opens up to, or half of the inscribed arc, or intercepted arc, excuse me. Angle 2. Angle 2 we said opened up to BC. That means it's going to be half of 96. Half of 96 will be 48. Now we look at angle 3. Angle 3 is over here. It opens up to 36, which means it's going to be half of 36, which will be 18. Angle 4 opens up to, once again, ED, so that means it's going to be the same measure as angle 1, which is going to be half of 100, which is 50. Angle 5. Angle 5 is here. It opens up to AE, which is 80, so that means that angle 5 is going to be half of 80, which is 40. Angle 6. 6 opens up to DC, which we said was 48, so half of 48 is 24. And our last angle, angle 7, opens up to AB, which is the same as open up to angle 3. So that means that 36 divided by 2 is going to give us 18 again. So each of these inscribed angles is half of the intercepted arc. So if we went backwards, if we knew what the inscribed angle was, instead of dividing by the arc by 2, we would multiply the inscribed angle by 2 to get the arc that it opens up to. So let's look here. Let's take a look at this problem. Using the inscribed angle theorem to find the measures of A and B. Now in this problem here, we're first going to look at finding A. Now A is arc P to T. If you follow the sides over here, it goes to point Q and P goes to point Q, so that means that this angle PQT is the inscribed angle. This is 60 degrees. So if this is 60, and that's half of the arc it opens up to, which is the arc PT, which is the same thing as A degrees, then it should be double this. So to find this, we're going to take 2 times 60, and that's going to give us 120. So we're kind of just working backwards. So now we have 120 degrees for arc PT. So now we're looking at angle B. Now angle B opens up from here all the way to here, which means you follow this out. It opens up to point P. It opens up to point S. So arc PS is the measure of the intercepted arc. Now we know that P to T is 120 and T to S is 30. So the total from this point here all the way around to this point here to S is going to be 150. And so that B, it opens up to 150. So to find B, we're going to take 150 and divide it by 2. That's going to give us 75. So this is 75 because it is half of the arc it opens up to, which goes from P to S. All right. Now you pause the video and try to figure out this one. When you're done, come back and check your answer. All right, let's see what you did. So we're looking for A and B. Now A is an arc that goes from this part to this part. Now there is no inscribed angle that opens up to A, because this goes down to this point here. This side goes down to this point here. 2 separate points. They don't meet and form one angle. So one thing we do know is that 52 degrees is the inscribed angle. So it opens up to the intercepted arc that goes from here to right here. And so that if we double this, our measure is going to be twice 52, which is 104. So this is 104. Now we know that 56 is from here to here. We know that 56 plus A is going to give us the entire arc. So to find the measure of A, you're going to take 104 minus 56. So A is equal to 48. Now let's look at B. B is an inscribed angle here that opens up to arc 56. That means it's going to be half of 56, which is 28. Let's go to the next one now. Now we have corollaries. Corollaries are just an addition to our theorem. So these are all going to apply to our inscribed angle theorem, but in this one we already kind of talked about. It says that if two inscribed angles that intercept the same arc are congruent. So these two angles here open up to the blue arc here, so therefore they would be congruent. So if you look at the example that goes with it, trying to locate the measure of angle 2. Now, if you look here, angle 2 opens up to this arc from here to here. Now 43 degrees, the other one they give us, opens up to the same arc. So these two both open up to the same arc, then they have the same measure, which means this one is 43 degrees. All right, let's go to corollary 2. An angle inscribed in a semicircle is a right angle. So if this angle, inscribed angle, opens up to a diameter is half a circle, so if this arc is 180, then this has to be half of it, which is 90. So we have a right triangle. So let's take a look here and find the measures of angles 1, 2, and 3. Angle 1 is an inscribed angle that opens up to a diameter. So we know this half is 180 degrees. Therefore, angle 1 is going to be a right angle. So that's going to be 90 degrees. Angle 2 is this angle right here, and it opens up to 70. So this is going to be half of 70. So angle 2 is going to be equal to 70 divided by 2, which is going to be 35. Now there's two ways to find angle 3. If we know that this is 35 and we know this angle 1 is 90, we can just do 90 minus 35, and that gives us that angle 3 is equal to 55 degrees. The other way to solve this is to know if this half is 180, then so is this. And if this is 70 degrees, then you can do 180 minus 70 to get 110 for the arc that goes from here to here. Angle 3 opens up to that arc, and so half of 110 would be 55 degrees. All right, let's move to the next one. This is probably the most confusing corollary. Opposite angles of a quadrilateral inscribed in a circle are supplementary. That means that if you have a four-sided figure that is inscribed inside the circle, which means all vertices are on the circle, then opposite angles are supplementary. And you know supplementary means they add up to 180. So angle A and C are going to be supplementary, and angle B and D are supplementary. So let's take a look at our example. We have A, B, C, and D. We need to find the measures of each of these angles. Now, we look here, we have arc AB is 100, arc AD is 120, and arc CD is 80. So we're missing arc BC. So what we have to do first is we have to go and find out what that measure is. So we take 100 and 120 and 80 and add them together. And if you take 80 and 120, that gives us 200. 200 and 100 gives us 300. So 300 subtracted from 360 gives us 60 degrees. So the measure of arc BC is 60. So now let's take a look at angle A. Angle A is our inscribed angle. It opens up to the arc that starts at D. It also opens up to the arc that starts at B. Now the total measure of this arc, DBC, or DCB, is going to be 80 plus 60, which is going to be 140 degrees. So we need to, it's an inscribed angle, so we're going to take half of it. So if we mark it from here all the way around to here as 140 degrees, then angle A is going to be half of 140, which is going to be 70. So angle A is equal to 70. Angle B, because of our corollary 3, we know that these two are supplementary. So we subtract from 180. So 180 minus 70 is equal to 110. So this is 110 degrees. So now we can either go to B or D, doesn't matter which one. Let's go to B since it comes first in the alphabet. And I'm sorry, I wrote this in B. This should be C down here. Now, so this measure from angle B, it opens up to A, and it opens up to C. So if we draw our arc all the way around, doesn't have to be pretty, mine's not, it means we have to know the measure of A to D and D to C. So we know this is 120, this is 80, which means it's a total of 200. And half of 200 would be 100. So angle B is going to be 100. And then angle D, our last angle, is going to be supplementary with angle B. So that means that this is going to have to be 80 degrees. So it helps to start by finding all the arc measures as you go around the circle, and then go back and find one angle, find its supplement, find another angle and its supplement, and then you're done. So let's look at one more theorem here. Theorem 1212. The measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So we have an angle down here, angle C, and its intercepted arc is going to be BC. So this line C is tangent to the circle. This line right here is a chord. So here's our chord and our tangent, which means it's going to be half of arc BC. Same thing with this. Okay, angle C is going to be half the measure of BDC. Same letters. This one's easier to spot because it's larger. This one's a little bit smaller, so sometimes it's hard to understand that this point right here is not only a inscribed angle, because its vertex is on the circle, but it's also where the arc ends as well. So let's take a look at an example here. What is the measure of angle DCB or DBC? Two ways to work this. Okay, they give us that arc BED is going to be 214 degrees. So we know that from D all the way back to B is going to be the rest of the circle. So we can find the measure of arc DB by taking 360 and subtracting 214. So what that gives us is 146. So now we can take the measure of DBC, angle DBC is going to be half of 146. And half of 146 is going to be 73. So if this is 146, then this angle down here is 73 degrees. Now the other way you could have solved this was just to take half of this one. This angle opens up from DEB. So angle ABC would then be half of 214. Excuse me, ABD. That would be 107. So if this is 107, and you recognize that ABC is a straight line, then these two would be a linear pair. So you could do 180 minus 107. That would give us 73 as well. So two ways to work that. Both ways are acceptable. You just have to pick one way and solve it. All right, so let's take a look at the last two problems. What are the values of the variables? I want you to solve for x and y. Pause the video, come back and see how you did. All right, so you should have gotten that x is equal to 35, y is equal to 55. The way we found this out is that x is this angle right here, and it opens up to arc JL. Well, inscribed angle Q, which is 35 degrees, opens up to the same arc, JL. And because these both open up to the same arc, then that means that both of these measures would be the same, so x is equal to 35. And because angle QJL opens up to a diameter, then this is a right angle. So we have a right triangle. And if we have two angles of a right triangle, we can subtract from 90 to get angle y. So y can be found by taking 90 minus 35, which gives us 55. All right, let's try the last one. This one we're finding the value of variables a, b, c, and d. So I want you to pause the video, solve this, but before you start to solve it, make sure that you fill in all the arcs around the outside first, and then go find the rest of your variables. So pause the video now and come back and check your answer in just a minute. All right, so let's look to see what we got. We know this right here is the diameter. You always need to look for the clues that they give you. So if this vertical line here goes through the center, then it's a diameter, which means this half of the circle is equal to 180, and so is this half. So if this is 120 from here to here, then from the remaining part from here to here would be 120 subtracted from 180, which gives us 60, which means E is going to be 60 degrees. Now, this one from here to here is 56, which means this half is going to be supplementary because it's going to equal 180. So you would do 180 minus 56. This will be for D, so I'll write it here. 180 minus 56. And that is going to give us 124 degrees. So D is 124 degrees. So now we've got all of our outside arcs measured. So now let's go back to A. A is this angle right here. It opens up to 60 degrees, which means it's going to be half of 60. So if we do 60 divided by 2, that's going to equal 30. So A is equal to 30. B is an inscribed angle that opens up to 120 degrees. It means it's going to be half of 120, so 120 divided by 2 is 60. And then we come down to C. C opens up to arc D, which we found to be 124. So we will take 124 divided by 2, and that gives us the measure of 62 degrees. So we get A is 30, B is 60, C is 62, and D is 124, and E is 60. So make sure that you, if possible, fill in all the measures of the outside before you start filling in the inside measures in any of these problems. That concludes lesson 12.3, Inscribed Angles.